Yeah. I wanted to thank Paul for that last talk, because to me that really embodies what these meetings are all about. And that's coming to share best practices. And as an industry, we come together here to try to help each other in a difficult task called finding oil and gas. So now for something a little different. So, okay, I'm going to have some geology in this talk, but I'm also going to have some history. And so why is the history important? And I would like to suggest that with the exciting things that are happening here in the Appalachian Basin today, the world is watching. But the world has always been watching, because the Appalachian Basin has been a key proponent of some of the techniques and technology transfer that has helped industry for a very long time. And at APG, we're celebrating our 100th anniversary. So I think it's a little bit fitting to take a few minutes and reflect upon some history. Now, I'm going to talk today about the Erie Canal and some of the things that made early geology possible. So, the basic outline, there are a couple of key characters. So there's a fellow named William Smith, and we've heard a lot about him from England, who did a map, the first map of England, that really helped the Industrial Revolution take off. And his story, William Smith, also known as William Stratus Smith, was popularized by Simon Winchester, who spoke at the APG in 2003 and also at the APG All-Convention Lunch in 2015, some of you may have heard of him. And there's also a couple of key people, a fellow named Hugh Torrance, who's a William Smith historian, and Amos Eaton is an American scientist, innovative educator, and what I love best, field geologist. And he was a contemporaneous with William Smith, 1776 to 1842. But the Amos Eaton story, he was our guy in the Northeast. He was not England, he was in the New World. His story is rarely told. So I had an opportunity to speak with Simon Winchester at the APG 2015 luncheon, and Simon talked about William Smith, the man, the map, and the democratization of geology, and how geology had a profound effect in England and on the Industrial Revolution. And we had a chance to speak together, Simon and I, we had a discussion about Amos Eaton. And he was familiar with the story, and he agreed that what Amos Eaton and the early geologists did in New York had a profound effect. So here's the British team. William Smith is on the left. Not shown is John Carey, the cartographer. Now, I couldn't find a good image of John Carey, but I found one of his maps, and since he's a cartographer, that represents the fact that he was able to come up with some really detailed, geographically correct images onto which William Smith could trace the geologic contents without having that background. And then, of course, Charles Lyell is a key figure in English geology. But we're going to focus on William Smith and then the American contemporaries. So William Smith's story is he started out as a canal digger. And so they were digging canals around the Somerset coal area in England because then, as now, energy is important. And back then, they needed to get that coal for the Industrial Revolution. And William Smith, as they cut these channels to allow the transport of the materials, he noticed the strata, and he noticed that it was dipping, and he recorded his observations. And he also realized that fossils were very important because certain beds had a lot of similar fossils, and that was one of the characteristics that help a field geologist as you go around and put together outcrops from different locations. He also made a very famous map, and we're going to look at it here in a moment. He is reported to have made 350 copies. These maps were very laboriously produced, and it's believed that about 120 or so still exist. And they have one on display in London, England. We're going to be going for the APG meeting in about 3 weeks, and we're going to see the map. But there are others in the United States and around the world. The way that it started back to the Somerset Canal, and this is near Bath, England, and you can see a picture of the canal in the lower right, was they needed to transport material, basically coal. And so they had some early maps because it was economically important to know where the coal was. And so part of the components that made William Smith's 1815 famous map possible is there was an understanding of where the coal was. So you can see in the southwest of England where the coal measures were. So he began with his work there because old geologic maps have to start with a few key layers. And then there was this sea urchin fossil called the poundstone that occurred in a particular bed, and that turns out, of course, to be the Jurassic outcrop belt. And so William Smith was able to see these very unique stones. During the early commerce, the stones weighed about a pound. The sea urchin fossil weighed about a pound. So if you went to a bakery and you bought a pound of something, they put in one. And if you bought flour, they measured. It was a system. It's just interesting that the fossil actually was a convenient. They were consistent enough that they were used as a standard for weight. But what William Smith noticed is that they occurred in a particular belt. So he put that on the map. So he already had a couple of key horizons. He had the coals, he had the Jurassic, and over about 20 years, he mapped out the rest of the layers. And so this is one of the maps, an image of it, and he used color to display the bands of like strata, which is kind of interesting because there are a couple of ways that he could have done it. He could have put little X's on a map every time he stepped on an outcrop, and we'd have a map of a lot of X's. But if you want to communicate a lot of information quickly, color banding is the way to go. And it was kind of a really good way to give an image of beds that were dipping. So there's one intermediate step before we get to the United States side of the coin. There was a fellow named William Maclure who was an early geologist as well, and he came to the United States. He was from Scotland, and he produced some cross sections, and there's a picture of him. He was not a big fan of the Erie Canal, which is going to be one of the stars of the show. He saw, as a person from the English Isles, he saw the United States as kind of an agricultural community, so he didn't really see the need for a canal and major development. So he opposed the Erie Canal, but he put together a map. So in all fairness, we have to recognize that here's a map of the Appalachians, and he used a very basic classification system called the Wernerian system. And basically, you can see our beloved Appalachians here. Basically, he broke it out into sedimentary rocks in blue. Yellow rocks are the float, which is basically soft sediments in the Gulf Coast, and then what they call primitive rocks, which are of course crystalline rocks, and they're shown in brown. So this was a basic map, but it did not have the dips of the beds, and it did not have fossils, and it didn't break it out into individual layers. This is basically just a really early attempt, but an important attempt. So now we get to basically the heart of the story. So let's talk a little bit about the American team. And it's interesting because there was a unique coincidence in the early 1800s in the United States of government. William DeWitt Clinton was the governor, and he wanted to promote growth in the state of New York. There was riches and financial backing by there was major landowner Stephen Van Rensselaer. And then the third guy on the right, the scientist, who for me is the hero of the story because he's the person who helped the government and the financier put together the geological information to useful purposes for society. So the geologic mapping, there was early work in 1815 by William Smith. But interestingly enough, Amos Eaton, and I think somewhat independently, we don't know how much communication there was. Later there was communication, but Amos Eaton became involved with the Erie Canal, and when you start digging a canal, you get fresh outcrops. So just yesterday, there was a bunch of us, we were out on the What the H field trip, and one of the really exciting parts of the trip was not just that there was incredible outcrops, but it was a new road exposing fresh outcrops. So a canal that exposed fresh outcrops, and if you're a naturalist and you start paying attention, that is how Amos Eaton put it all together, started to put it together. He provided key scientific information. So just like in Simon Winchester's book, he likes to tell the story how William Smith had many trials and tribulations. You know, a good story ends where there's a hero, they kind of do something great, then they kind of get put in prison or something horrible happens to them, and then they get redemption at the end. Well, actually, both Amos Eaton and William Smith did wind up in prison for different reasons. Amos Eaton's situation was he was falsely accused, at least that's what we like to believe, and so he was put in a prison for some kind of legal technicality issue. But while he was in prison, he was teaching natural science to the inmates. And the son of the prison, I guess the warden of the prison, the son really took a liking to Amos Eaton. So Amos Eaton became, he had his struggles, he had his challenges, just like William Smith. And he basically wanted to be able to go out and teach science. And so he was able, there were some things happening around the War of 1812. They needed a talented person, such as himself, and he became available to help with this project. So he began, this is an 1818, this is a 500-mile long cross-section from the Catskill Mountains to the Atlantic Ocean. It's the longest transect of its day, and he actually showed the individual strata, their dips, and it's going, you can see there's the Catskills on the left and out to the Atlantic Coastal Plain on the right. So this was a really beginning to his effort. And the Erie Canal, so this is an elevation data set. You can see there's a natural proclivity for low-lying waters to move, let's see if I, there we go. So to move from the Great Lakes through the Mohawk Valley and then into the Hudson Valley and ultimately to get down into the Atlantic Ocean. So there was a natural geologic proclivity to build the canal. And one of the interesting things, and Amos Eaton, when he went out and did some mapping, there was a glacial lake, ancient glacial lake in Ontario. So the Helderberg Escarpment, which is an absolutely amazing thing, and I was enjoying Dr. Bob's discussion yesterday in the award ceremony when he got the Gailey Award, and he described how he drove across to the University of Buffalo where he was teaching. There's this major Devonian escarpment down to the south, and there's a huge cliff face that I've known as a kid for at least 40 years. We used to go there because you could have incredible views out into the low-lying area. Well, that low-lying area was the site of Glacial Lake, Ontario. And this is what that escarpment looks like. You see these incredible cliffs of the Devonian. So for fans of the Devonian, this is the view to Albany down here. It's a little bit fuzzy, but you're up on the upside, and you can see the whole valley to the north, and you see these incredible geology cliff faces, and you can actually go down a thing called Indian Ladder. And if you're a geologist, you can just have an absolutely wonderful time going up and down the entire exposed Devonian section. So this was a key part of why the canal is at the base of this escarpment, and it was key to Amos Eaton's geological work. So this is where the Erie Canal wound up. It was on the north side of that escarpment, and so it went through places, connected up into the Great Lakes, Buffalo, Fairport, Syracuse, Utica, Little Falls. There's a little bit of a high section in here, and then it basically came back down into the Hudson River Valley and connected up. And so this is a profile showing, so like a lot of canals, so you go to the Suez Canal, there's not a lot of elevation drop from one part of the canal to the other part of the canal. you go to the Panama Canal, this was really something interesting to me when we went there, is the canal actually through a series of locks goes up over a mountain range and then comes back down. So the Erie Canal was mostly about 570 feet up in the Great Lakes to zero at the Atlantic Ocean. But it's not a complete smooth down, so each of these little steps are locks along the way to the canal. And there's a middle section in here where they actually had to raise the water level up, and then of course there was the big drop down on the way to the Atlantic. But this was the section of the Erie Canal. And by the way, the Erie Canal, just coincidentally, is celebrating its 200th anniversary, so everybody likes, 100-year anniversaries. This is a 200-year anniversary from when the canal was work was begun. And why was it necessary, and what is its importance? Well, it was key to unlocking the United States to the axis of immigration. It was difficult to get into the interior. It was landlocked. And New York had some absolutely amazing, because of the Hudson River Valley and because of the topographic lowlands that we just looked at through the Mohawk Valley, it had an access to the Great Lakes. And once you got into the Great Lakes, this is kind of an interesting thing. At Chicago, which would ultimately become a key part of the story, you could get to the Mississippi River. And if you could get to the Great Lakes, and if you could get down into the Mississippi River, you could pretty much get anywhere. So it opened up the entire continent. So some of the factors, as Amos Eaton was providing the geological work to help build the canal, what they were looking for, what they were hoping to find was economic resources. So they wanted to find coal, like in Pennsylvania. What he found instead was not so much coal, but he found salt and a lot of construction materials. And along the way, he did notice some hydrocarbon seeps. We'll come back to those later. But as in most great efforts, it was heavily opposed at the beginning. So people derided the whole idea of building a canal, calling it Clinton's folly, Clinton's big ditch. Remember, Clinton was the government guy who was sort of trying to make things happen. But its other notable facts are it was 363 miles long with 36 locks. And the key economic driver was that it was 95% faster. That's like a lot. Cheaper than pulling material along with barges pulled by animals. So the way that they would move material before the canal was open to easy access was they would actually have animals walking along the side of the shore, pulling a barge. And so the canal, and that required all kinds of portage, and people would have to move things, and it was just a very inefficient transportation system. So for goods and services, this opened up the commerce. And what Simon Winchester told me when we talked in 2015, basically the Erie Canal made New York, New York. The Erie Canal made the entire harbor of New York accessible to the inland of the United States. Otherwise, we would not have the commerce that we do, and New York City would not be the great resource that it is. So, in the Albany New York State Museum, they have a lot of displays on the Erie Canal. And one of the things I hope to do someday, and perhaps some of you have done, is you can access parts of it. And they actually have ways that you can take boats and go along parts of the old Erie Canal. So this is near Mohawk Falls. It's an amazing waterfall. And one of the things in the early days was it was recognized the water was used, of course, to power industry. And this is the map that kind of shows that once you get into the New York Harbor and get into the Erie Canal and get up into the Great Lakes, and you can potentially maneuver your way around to Chicago. And I'm not sure how smooth the linkage was, but ultimately you could get into the Mississippi River and you would have access, let's see, follow the Mississippi, you'd have access to the entire big continent. So it really had strategic importance. And some of the work, this is from Amos Eaton Publications. These are what the locks looked like in the 1830s at Little Falls, New York, Rochester, New York, and Albany, New York. And my wife Linda and I, we did a tour. Linda's here today. A few years ago, we were celebrating our 30th wedding anniversary, and we thought we'd go back to RPI, where we were students. And by the way, we happen to be involved in the APG student chapter, just mentioning that, since APG is an important part of our lives. And we got to visit the library at APG, at RPI, and they have, not only do they have one of the slightly more than 100 William Smith maps, it's folded up in a book. So it's not displayed hanging from the wall like the one in London is, but it's a lot of the books were, the maps were made in folded form and put into a book. But Jerry and Sue Friedman, and many here in the Eastern section, okay, I asked this at the opening ceremony last night. So how many people here remember Jerry Friedman? A few? A few, yeah. So Jerry was one of the Gailey awardees. We're very proud of Jerry for that. And one of the things he did was he loved buying historical books. So he has some of the most incredible early history of geology books that are available to be visited at the RPI campus. And so this is where I was able to actually look at some of the 1815, 1820 Amos Eaton material, which he donated. And so just a few words about Amos Eaton and his trip. So Amos Eaton realized to really understand the geology of New York, you had to get out in the field. He really was a field geologist, and he had to build a lot of the techniques. So he went up and down the Erie Canal 5 separate times. The first time during the years of 1822 to 1824. The first time was a recon mission. The second time he was focusing on the glacial drift. The third time he was really looking for economic resources. The fourth time he was getting away, he mapped out the early layers, and then he was going out and getting away from the canal to fill in other data points for the geological map. And then they found some interesting things. In the fifth, there was glaciated deposits that had covered Pleistocene forest. And all along the way he was teaching. So he was one of these, kind of like a minister. You know, he kept teaching geology to anyone who would listen. And he was a very progressive educator. These are some of the things from his diaries. And I always love looking at geologists' field notebooks. Well, here's in his own hand some of his sketches. These are the beds dipping into the Appalachian Basin. From here's the Helderberg Escarpment, and then here are the beds dipping south into the Appalachian Basin from the Helderberg Escarpment. And he also had notes about the boat and who was on the boat. They were very smart. They got a lot of the politicians they needed to help support the effort, and people who were helping with the research got to participate. And he was a big fossil collector, and he made extensive notes about the rock types so that he could break out the individual strata. So he wanted to get it way beyond the level of metamorphic and sedimentary and float. He really wanted to get it down to the specific types of fossils and layers. And this is one of the published versions, 1822, of one of his cross sections. This is an east-west cross section across. Once again, this is through, I believe, the mountain belt heading over to the Atlantic. So and here's the map. Okay, so here is the New York map that he published in 1830, and it's pretty remarkable because you can see up here, up on the Helderberg Escarpment, these layers were sandstones. These were the various carbonate layers that we now know to be Devonian and Silurian. And then in here is largely where the canal comes through, at the base of the cliff. And then these mountain ranges north-south mountain ranges and Adirondacks. These, of course, were the crystalline rocks. And so you can see here also the Helderberg Escarpment, and you can see some of the thrust in the mountain ranges as you come across through this area. And now this area is very important, and we'll talk about that in a minute. This is detailed breakdown. Once again, sandstones, capping, carbonates in here, carbonates and transitional rocks down in the escarpment, and then of course the primitive, what they call primitive, but basically the Precambrian. Okay, so now, is Dr. Bob in the room? Hey, Dr. Bob. So when you showed last night your journey across New York and how you found faults, and after seismic events, they gave off thermogenic gas, I thought that was absolutely fascinating. My buddy, Ray Sorensen, who's into the history of petroleum geology, has gone back and looked at pre-Drake oil and gas shows all throughout the United States. Ray is one of these book collectors, a lot like Jerry Friedman. And Ray basically found that of all the areas, New York, he said, had more oil and gas shows in the literature. Maybe it's because it was heavily traveled, maybe because there was a lot of people paying attention. But here's the Cuba, where there were some shows at Cuba. Here's the Fredonia. So pretty interesting that people were logging as they were moving around back and forth along the Erie Canal, that there were a lot of oil and gas shows, which interestingly we now know why a lot of them are there. And of course we give credit to the Marcellus and mainly, I think. So this is the map that Amos Eaton produced, and this is the map on the left. And they're about the same scale. And the thing that I wanted to point out is that, yes, England is a bigger scope, but that within a very few years, here in the New World, there were geologists like Amos Eaton who were really putting together the history of what was to become the map-making, the geology map-making. And what I would say is Amos Eaton's greatest legacy is not just the map that he made to help with the Erie Canal development, but his greatest legacy was in training people to go out and make maps like this so that they could go elsewhere. And for me, in the words of APG, that's technology transfer. And so we'll talk about that in a minute. 1818 to 1836 is known as the Etonian era in the U.S. And he did visit with Charles Lyell right before his death. About 1 year before Amos Eaton died, he had a chance to talk to Charles Lyell, and they talked about sharing best practices, if you will. But I think for the most part, a lot of what Amos Eaton did was pretty much homegrown. And I put this in because it's kind of interesting. I've always been wondering, so the geology is here. This is Pangea Reconstruction. And William Smith and the British team were working over here. So they weren't like England and New York and the Appalachians weren't snuggled up right against each other. Africa was sort of in between. But they were close enough, and they were basically describing the similar types of geology. But back to Amos Eaton's legacy. So he founded a university, RPI. I'm very thankful for that, since I was able to go to school there. And I got my master's and doctorate, and also I met my future wife, Linda, who's a geologist as well. It is the site, up until that time, there was not many places where you could go to get an engineering education in the United States. West Point was one of them, but RPI opened up the ability for people who wanted to get field-based geoscience and engineering in a practical way that weren't otherwise going to West Point. And the Eaton method was, he was very practical, and he had techniques that he would basically, it was all about the field exercises. So the critical thing wasn't just to have a professor lecture, but it was for you to go out and work the problem with the professor and then switch roles. So now you're the professor, and you're explaining it to the class, and you're explaining it, the student would explain it to the professor, and would explain it to the other student. So it was a very powerful way of teaching. And so, here's another modern word, experiential learning. This is a big thing that APG is very cognizant of. A lot of the most effective learning is when you're actually doing. And that's why our IBA program, I think, is so successful, because people come together, students come together, and they try to solve a problem together. And this is a little bit of poetic stuff, but in some of the books I've written about Amos Eaton, there was a geological imperative that science was going to help make the world a better place. And there was a very significant time, 1825, when they finally completed the canal. There was a boat called the Seneca Chief, a barge, that brought waters from the Great Lake and deposited in the Atlantic. So it was the beginning of what was felt to be future unprecedented prosperity. So now, a word about people moving out. So of the Amos Eaton graduates, many of them went on to found geological surveys. It was the golden age where all of the rest of the United States needed, at least certainly starting on the East Coast, needed to understand geology. And we were talking last night, one of the people I was talking to last night is at the North Carolina survey, and a guy named Emmon was one of Amos Eaton's students. And so it's pretty interesting that there was a huge effort of students moving out. So here is the thrust belt. This was this was reflected on Amos Eaton's map and on his cross section, and this goes right through the RPI campus, and we used to visit it all the time. So this is the fold and thrust belt, and this is the plateau in front of it. And as we were driving around on the Wonder Beach field trip, we passed over the leading edge of the thrust belt a couple of times, and so that was kind of exciting for me when we went through that in West Virginia. But that was a major structural recognition, and Ebenezer Emmons was, as I say, one of Amos Eaton's students. And so, while we were students, and back to Jerry Friedman, because there is a connection, I think. When Lynn and I were students at RPI, we often thought that there was kind of a resemblance between the two. And there certainly was a resemblance in teaching methods. Jerry was very much into the practical and applied science and changing roles, where the students would have to present in front of other students and defend as if they had written various papers. So he used a lot of Eaton's teaching techniques. And so it was a real thrill. Jerry, of course, received the Powers Medal, and there's a nice write-up. He was an amazing individual, and he really tried to promote the history of science. And so it's because of him that we took an interest in the history and the role that the Northeastern region has played in science. And so a few years ago, Lynn and I got to visit with Sue, Jerry's wife. Now, Jerry passed away, I believe it was 2011, but Sue, his wife, in case anyone still remembers Sue, she has moved to Israel. She's with her family in Israel, but she's doing great. And she took us around Troy, New York, where they have some amazing people. So Amos Eaton is buried in the Oakwood Cemetery, and we visited Amos Eaton's grave, and Oaklawn Cemetery. And another interesting person, and Jerry always liked to point this out, Sidney Powers is interred in Troy, New York, and he used to take students there. So imagine that. I mean, they would go up and they would observe geology and glacial lake geology from the hills, but then they would always stop and pay their respects to some of the greats in the industry. So that's it. I would like to thank some people. I need to give credit to Hugh Torrance, who's done a lot of the great work on William Smith, and who Simon Winchester was able to access in the popularization of William Smith and the map that changed the world in 2001. Peter Wigley, who's also a William Smith historian, and we're going to be visiting here in just a few weeks in England. There's a great book by 2014 book, DeWitt Clinton and Amos Eaton, by WPI professor David Spinagle, and we're very thankful to the support from RPI and the collection of the wonderful historical geology collection that's available to anybody who's interested to come visit at the RPI campus in Troy, New York. And so the goal of this talk was to talk about the history of petroleum geology in England, the map that changed the world, but to reflect on the fact that at the same time, in the Northeast, that there were workers that created the map that changed the New World, that opened up the continent, and that also trained people, geologists, to be able to go out and bring those skills to make the world a better place. So, ladies and gentlemen, I thank you.